Greetings to all grade 11 and 12 learners out there. What we are going to do today, we are going to deal with sine and cosine rule and also move to the area rule. The purpose for this is to introduce you to grade 12 trigonometry 2D and 3D. I know that this is something that you might have done last term, but I know that since it was not examined, some of the teachers in your schools might have left it out. Okay, but as you know, we cannot just go straight to 2D and 3D. We've got to start somewhere. I'm going to take you a little bit back to grade 11, where we proved and applied sine, cosine, and also the area rule. Okay, we're going to start by proving a sine rule. Okay, now what does sine rule says? Now sine rule says that in any triangle ABC, it is true that A over sine A is equals to B over sine B equals to C over sine C. I hope my handwriting is clear and you can see everything that I'm writing there. Or sine A over A is equals to sine B over B equals to sine C over C. Now, when do we use all these rules? Like I said, the sine, cosine, and also the area rule. You will remember that in grade 10, when you were introduced to the trig ratios, it was emphasized that the trig ratios only work in a right-angled triangle. You see? Because if you remember the SOHCAHTOA, sine requires a hypotenuse, cos requires a hypotenuse, and you only find the hypotenuse in a right-angled triangle. So you know that if you have a right-angled triangle, to calculate the side, the unknown side, or the angle, you can use the trig ratios or Pythagoras theorem. But now, what if you have a triangle that is not a right-angled triangle? For an example, that triangle there, let's call it A, B, C. According to the classification of triangles, that one will be an acute angled triangle because all the angles there are acute angles. Or if you have something like that, an obtuse angled triangle, because one angle is an obtuse angle there. Let's also label it A, B, C. Now let us name these sides. The side opposite to an angle will be a small letter of that angle. As you can see, this side BC is opposite to this angle A, so this will be small a. Looks like a Q, but it's an A. Side AB is opposite to this angle there, so this will be small c. Okay, now this is an acute angled triangle. As you can see, it is not a right angled triangle. So we want a rule that will help us in calculating unknown side and angles if we do not have a right angle triangle. Like in any other triangle, if BC is a base, we need to construct a height there. Remember that a height must be perpendicular to the base. So this is the height of this triangle. I can construct the height in any way I want. I can construct it from this apex perpendicular to this base. I can construct it also from this apex such that it will be perpendicular to that base, and then also from this apex it will be perpendicular to that base. But so that it will be easy to understand, I will construct it from this apex A, so it will be perpendicular to BC. Now this point where my height meets the base BC, I will call this D. Okay, I'll call it D. A is the whole side of BC, and then D is the point where my height meets the base of BC. Okay, now let us look into, in triangle, we're just focusing on this triangle this side. Let us look into triangle ABD. Now triangle ABD is this triangle. Can you see that it is a right angled triangle? It's a right angled triangle because we've got a right angle there. Okay, so if I say sine B for this triangle, okay, remember for sine it is opposite over hypotenuse. The opposite, if B is here, the relationship here, the opposite for this angle is the height, so it will be h over small c, which is the side. Height over hypotenuse, this is for sine. Now if I'm looking for the height, then the height will be equals to, cross multiply there, remember this is over 1, so it will be c sine B. Okay, so I have my height there. Okay, now let us look into the other triangle. Okay, now in triangle ACD, the other right angle triangle, can you see ACD? This is a right angle triangle. If this is a straight line and you have 90 degrees there, so it will mean I also have 90 degrees this side. So if I'm looking for sine C will be equals to, remember sine is opposite over hypotenuse, and if I'm here, my opposite here is h and the hypotenuse is b, so it will be opposite over hypotenuse. So if I'm looking for the height, again the height will be equals to b sine c. Okay, I hope it's clear. Now look at this. I have my height here equals to this c sine b, and here I have my height b sine c. But you notice that I'm talking about the same height, this height. I'm talking about the same height, okay? But it's equals to two different things. Now, if this is the same height, if we agree that this is the same height, it will mean this is equals to that. So I can safely say that c sine b is equals to b sine c. Okay, now let me divide by BC, both sides. You can see these will divide. These will also divide. So here I'll be left with sine B over B equals to sine C over C. Okay. Now it can also be proven that sine A over A is equals to all this, but you do not need to prove all this once you have proven 2. Okay. Now you can see that we've got the sine of the angles on top, and these are sides on the bottom there. You can also flip this and have B over sine B equals to C over sine C equals to A over sine A. So you use this, you equate 2 of this depending on what you are looking for and what you are given. You can equate any 2 if you are looking for the angles, okay? And you can equate like this with the sides on the top if you are looking for a side, okay? Now, what if you have an obtuse angle triangle and you want to prove the same thing? Okay. Now, let us name the sides here. Remember, a side opposite to an angle is a small letter of that angle. So this is A. That means we have a small a there. A B, a side opposite to B, will have a small b there. A C, a side opposite to this angle, so we have a small c there. Now for an obtuse angle triangle, if you want to construct a height there, obviously it will have to be outside from apex A. We are constructing a height there. Remember that a height must be perpendicular to the base. Let us name that point where the height meets the base extended. Let us name it D. Okay. Remember, if BC ends here and I extend this on a straight line, so if I construct my height there, if my height is perpendicular to that line that is extended from straight line BC, it will also be, my height will also be perpendicular to this base. So remember, the height must be perpendicular to the base. Now here, let us do the same thing. Let us look in triangle, the big triangle A, B, D, in triangle A, B, D, and we are looking for sine B. Remember, big triangle. Can you see that is a right angle triangle? Okay. So sine B for this triangle will be opposite over hypotenuse. It will be H over C. So the height will be C sine B. See the same thing that we found there. Okay, we've got our height here, and then now we look into the smaller triangle, this triangle. Okay, so we're looking to in triangle ACD. Now let's take a look at this. If I hide this, you would agree that I would call this angle C, the angle that is inside this original triangle. See, if I hide this triangle will be C. Now this is a straight line. Okay, so this angle, this side, Remember, a straight line is a 180 degrees, but I'm looking for this angle. So it is 180 degrees minus C. It's this triangle, okay? Sorry, it's this angle. So if I'm looking for now sine 180 degrees minus C, this will be equal to the opposite over hypotenuse, which is my height over B, okay? And then check this. Remember the reduction formulas? Still on trigonometry, you did them in term 1. Which quadrant is this? Okay, 180 degrees, 180 is this, minus C, it will take you to this quadrant there, which is the second quadrant, and sine is positive in that second quadrant. So this is the same as sine C equals to H over B. And then if I'm looking for the height there, height will be equals to B sine C. Okay, again, remember we are talking about the same height. This is the height that we are talking about. This same height is equal to this. Again, the same height is equal to that. So I can safely equate these two. So C sine B is equal to B sine C, and then I divide by BC both sides, and then these will divide. Here I will be left with sine B over B equals to, again these will divide, sine C over C. Again, it can be proven that sine A over A is equal to both this. Again, you do not have to prove this once you've proven these two. The same thing you can do. This is for calculating the angles. If you want to calculate the sides, you can go back there. Okay. So you've got to be able to prove if you are given an acute angled triangle, and also if you are given an obtuse angled triangle. Okay. The key here in proving here is that you've got to know how to construct the height. Okay. If you are constructing the height for an obtuse angle triangle, it will be outside. Okay. So you've got to know that. And also here, you must know which angle to use here. We're focusing on this angle, which is 180 degrees minus C. Now, okay. Now I want us to see how do we apply this rule, the sine rule. Now first, you've got to know when to use the sine rule and when to use the cosine rule. Now with the sine rule, you use it where you have the angle and the side, and you are looking to find another side. Okay, so we use this rule when we have the angle and the side, and we are looking to find another side. Okay, or we can use it If we have a side and an angle, and we are looking for an angle, okay? If you have a side, you have two sides and an angle, and you're looking for an angle. If you have two angles and a side, and you're looking for a side. Now let us take a look at these two examples here and see where do they fit here. Take a look at this one. Here the instruction says calculate x, okay? And you can see that x here is a side, okay? Remember, when we're looking for a side, we must have two angles and one side. Now let's check whether we've got that. We're looking for a side, we've got two angles and the side, okay? So here we can be able to use this this rule, okay? Let's look at this side. The x here is an angle, the unknown is an angle. Now if we're looking for an angle, we must have two sides and an angle. Let's see if we have that here. We've got the side, we've got a side, and we've got an angle. So we can apply sine rule there. Okay. Now remember, if we are looking for a side, remember what we said here. Remember what we said here. If you are looking for a side, then the formula there has got the sides on top. That is the one that must be used. Okay. If we are looking for an angle, then we must have angles on top. Okay. All right. Now here we are looking for a side. Okay. Now let us formulate our own sine rule here. Sorry. Let us formulate our own sine rule here. This is a side, okay? So it will be x over the sine of an angle that is opposite to this side. So it will be sine 60, okay? It will be sine 60 degrees, okay? Equals to, so it will be 15 over sine 55 degrees. Now can you see that you are looking for x, and this you do not want, and you can apply multiplicative inverse. You want to eliminate this, so you are going to multiply it by sine 60 both sides, and these will divide. Here you'll be left with x equals to 15 times sine 60 degrees over sine 55 degrees. And you can go straight to your calculator to find that. And remember, when you are using a calculator in trigonometry, you must make sure that your calculator is in degrees. As you can see, this one is in radians, so we've got to change this one to degrees. Okay, now let's change it to degrees. Right, we have changed it to degrees, and what we need to do now is to just to insert this on our calculator, and we've got our answer. So this is 15 times sine 60 degrees. Okay, excuse me. Okay, and then we divide by sine 55 degrees, and here you can see our answer. We've got to round off to 2 decimal places, as you can see. The second digit after the comma is 5, and the third one is 8, so this have to go up. So we'll have 15,86. This is in centimeters, and that is the size of x. Okay, now let's take a look at this side. Now here we've already seen that we've got two sides and an angle, and we're looking for an angle. And if we are looking for an angle, remember we're using an equation that has got the angles on top. So here it will be sine x over the side opposite to x is 25 equals to, this is sine 36 over 19. And again, this is what we are looking for. We do not need this. Again, we apply multiplicative inverse, so we multiply by 25 both sides, and these will divide, and then you'll be left with sine x equals to 25 sine 36 degrees all over 19. And then now we're looking for an angle. It's x equals to, I prefer to put it as it is on my calculator, because if I calculate it like this, I will have to round off, and my answer there will not be accurate. So I prefer putting it as it is. When we are calculating an angle, this is sine x sine of 25 sine 36 degrees all over 19. This is 36. So I prefer putting it as it is on my calculator. So let's see how it's done. So I go to my calculator. Here it is. This is, I put second function sine, and I want to put everything as it is there. So it is 25 times sine of 36, I close the bracket, all over 19, and then close the bigger bracket. And this is an angle, so this will be 50,66 degrees. That is an angle there. Okay. Okay, now I want us to take a look at this. I want you to try this on your own. This is a triangle. You are asked to calculate x. Now look at this. You've got, this is 97,9 degrees. It's an angle A. This is 29,7 degrees. And then you've got 5 there. And we are looking for x. Now I want you to pause the video and try this on your own. You also try this one on your own. As you can see, now we are looking for an angle. This is 52,4. This is 5. This is 8. And we are looking for an angle there. Okay. Please pause the video and try this on your own. Right. I hope you really pause the video because I want to show you how you should have done this. Remember, we are looking for the side here. Now, when we are looking for a side, remember this is what you must have. You must have two angles and a side if you are looking for a side. Now, let's see whether you've got the side here. Okay. Let's see whether you've got enough information. Okay. You've got two angles and a side. Yes. And you're looking for the side. So the information is enough here. Okay. Now let's see what we're supposed to do. Remember, you're looking for the side, so the equation to use will be the one that has got the side on top. Okay? Right, now let's see. So we've got an x over the sine of an angle that is opposite to that side. Here it would be sine 97,9 equals to what you have. It is 5 over sine, 5 is a side, over the sine of an angle opposite to that. This will be 29,7. And remember, you are looking for an x, so you multiply it by sine 97,7 both sides. Again, multiply it by sine 97,9. Sorry, it's 97,9. Okay, and then you'll have x equals to 5 sine 97,9 over sine 29,7, and you just do that on your calculator and you will realize that x is equals to 10 units. It's actually 10,999, and you can round it off to 10. Now let's take a look at the second one. Now if you are looking at this one, we are looking for an angle, which is an x. Remember, when you're looking for an angle, you must have two sides and an angle. Let's see if we have that. We've got two sides and an angle, so the cosine rule will be applicable there. Okay, now let's see. We've got an angle 52,4 there, and what we're looking for is an angle. Remember, when you're looking for an angle, the equation with the angles on top, that is the one that we must use. So here we have sine x over the side that is opposite to that angle. In this case, it is 5. And then this side, it will be equals to sine 52,4 over 8. Again, this is what we are looking for. Multiplicative inverse, we multiply by 5 both sides, and then these will divide. We will have sine x equals to 5 sine 52,4 all over 8. Like, again, I've said it before that I prefer putting it as it is on a calculator, so that it will give us the most accurate answer. Okay, so this is x equals to x sine, this is 5 sine 52,4, sorry, all over 8, and then you will find that this angle is equals to 29,87 degrees. Now, I would like you to practice this. The most appropriate book where you will find the exercises is a grade 11 textbook, because this is found in grade 11. So make sure that you go to your grade 11 book and practice this. Okay? Thank you.